The topic for Lesson 6.5 is parts of similar triangles. You'll learn to recognize and use proportional relationships of corresponding perimeters of similar triangles, and recognize and use proportional relationships of corresponding angle bisectors, altitudes, and medians of similar triangles. How is geometry related to photography? The camera lens was 6.16 meters from this Dale Julie glass sculpture when the photograph was taken. The image on the film is 35 millimeters tall. Similar triangles enable us to find the height of the actual sculpture. Triangle ABC is similar to triangle DEF with a scale factor of 1 to 3. You can use variables and the scale factor to compare their perimeters. Let the measure of the sides of A, B, and C be lowercase a opposite the angle A is the common way of naming it, lowercase c opposite the angle C, and lowercase b opposite the angle B. The measures of the corresponding sides of triangle DEF would be 3A, 3B, and 3C because it's in a scale factor of 1 to 3. So if we find the perimeter of triangle ABC, it would be A plus B plus C, and the perimeter of triangle DEF would be 3A plus 3B plus 3C. We can factor a 3 out of the denominator, and I guess a 1 out of the numerator. So A plus B plus C, that sum, is the same in the numerator denominator, and we remember that anything divided by itself is always 1. So the perimeters are in a ratio of 1 to 3 as well. The perimeters are in the same proportion as the side measures of the two similar figures. This suggests theorem 6.7, the proportional perimeters theorem. So theorem 6.7 states, if two triangles are similar, then the perimeters are proportional to the measures of the corresponding sides. If triangle ABC is similar to triangle XYZ, and AC is 32, AB is 16, BC is 16 squared of 5, and XY is 42, find the perimeter of triangle XYZ. Okay, they were nice when they made the diagrams and put them in the same orientation. We could mark the angles if we wanted to. A corresponds to X, and it looks like it's a right angle, but I don't know, so I didn't mark it as a right angle. B corresponds to Y, and so therefore C must correspond to Z. So my corresponding parts they gave us were the 24 and the 16, and they gave us all the parts for the smaller triangle ABC so we can find its perimeter. So we have XY is to AB as, I'm just going to go P for perimeter of triangle, and that was in triangle XYZ, is to perimeter of triangle ABC. So XY they gave us was 24, and AB they gave us was 16. The perimeter of triangle XYZ is what we're trying to find, so I'm going to let that be X, over the perimeter of triangle ABC. 16 plus 32 is 48, plus 16 square root of 5. I can't simplify that. Okay, so then we can do cross products. So I have 16x equals 24 times 48 plus 16 square root of 5. And then I'm just going to use a calculator to divide both sides by 16. And I get x equals 72 plus 24 square root of 5. And your smart calculators will handle the radicals and everything, so you've got life pretty good here. Okay, this next three theorems all kind of have a common theme, so I'm all right with you not writing all of this down if you don't feel like you need to. If you just want to listen along, that's okay too. If it helps you to learn it, to write it down, write it down. Okay, so theorem 6.8, if two triangles are similar, then the measures of the corresponding altitudes. Remember, altitude is a segment that connects to the vertex and is perpendicular to the opposite side. So those are both altitudes there. The altitudes are proportional to the measures of the corresponding sides. Okay, so altitude is a special segment of the triangle. It makes sense that all the parts of the triangle will be proportional. And they wrote out all the proportions there. Another special part was the angle bisector. Angle bisector bisects an angle and connects to the opposite side. So if two triangles are similar, then the measures of the corresponding angle bisectors of the triangle are proportional to the measures of the corresponding sides. And then we had another special part named the median. The median connected the midpoint of a side to the opposite vertex. So if two triangles are similar, then the measures of the corresponding medians are proportional to the measures of the corresponding sides. Triangle ABC is similar to triangle MNO, and BC, circling that, is 1/3 of NO. Find the ratio of the length of the altitude of ABC to the length of the altitude of MNO. Well, in Theorem 6.8, they said that if two triangles are similar, then the measures of the corresponding altitudes are proportional to the measures of the corresponding sides. So if our corresponding sides are related in a ratio of 1:3, the altitudes are related in a ratio of 1:3. In the figure, triangle EFG is similar to triangle JKL. ED is an altitude of triangle EFG, and JI is an altitude of triangle JKL. Find X if EF is 36, ED is 18, and JK is 56. So our relationship ED is to JI, so those are our altitudes, as EF is to JK. And so we can just fill in our numbers and do cross products. So they told us ED is 18. We're trying to find JI. EF is 36. And JK is 56. Cross products again. So we have 1008 equals 36x divided by 36, and we have x. So x is 28. Another nice use of proportions in solving with cross products. The drawing below illustrates two poles supported by wires. Triangle ABC is similar to triangle GED. AF is congruent to FC. Okay, so if that's both the same, then if they'd both have to be 40. And FG is congruent to GC is congruent to DC. So if these segments are the same and they both add up to 40, then they would each have to be 20. So that means that guy is 20. Find the height of the pole EC. Okay, so our proportion is going to be BF is to EC. So we've got pole is to pole, as AC, that's our whole base of our triangle, is to GD. Okay, plug in the numbers that we know. So BF is 30. EC is what we're trying to find. AC is 80. And GD would be 20 plus 20, which is 40. Do our friendly cross products again. So we have 1200 equals 80x. Divide by 80. and x is 15, which some of you guys probably eyeballed it and said, hey, 40 is half of 80, so our answer is going to have to be half of 30. Yeah, you're right. An angle bisector in a triangle separates the opposite side into segments that have the same ratio as the other two sides. So in this one, we have AD is to DB as AC is to BC. So the numerators are segments with vertex at A, and the denominators are segments with vertex at B. Okay, let's do an example of that theorem. I like simple directions. They just said find x. So using theorem 611, we could set up a proportion that x is to 9. So that's bottom part to bottom part is to, okay, so the side adjacent to the x here is the 18. The side adjacent to the 9 is 24. So we're going to go in the same direction. So 18 is to 24. And then once again, we're solving proportions, so we're doing cross products. So we have 24x equals 162. Divide both sides by 24, and we have x. And I'm going to write as a decimal 6.75. Summing up lesson 6.5. Similar triangles have perimeters that are proportional to the corresponding sides, and corresponding angle bisectors, medians, and altitudes of similar triangles have lengths in the same ratio as the corresponding sides.